Deep in the ocean, past the point where sunlight ever reaches, a small red jellyfish suddenly lights up in a spinning ring of bright blue flashes. It isn't hunting. It isn't trying to attract a mate. It's under attack, and this light show is its emergency alarm, calling something bigger and more dangerous to come rescue it by attacking whatever grabbed it first. This is one of the strangest uses of light found anywhere in the ocean, and it belongs to a group of deep-sea jellyfish that can produce their own glow, using nothing but chemistry built directly into their own bodies. In a place with zero natural sunlight, these animals essentially carry their own light source wherever they go. So how does a soft, simple jellyfish actually make light? And why would it want to glow at all in a place built entirely around staying hidden in the dark? Let's start with how the light itself actually gets made. Because it isn't anything like a light bulb or a flame. Many deep-sea jellyfish produce light through a chemical reaction happening inside their own cells using two main ingredients. The first is a molecule called luciferin, which is capable of producing light when it reacts with oxygen. The second is a special protein called luciferase, which speeds up and controls that reaction. When these two combine under the right conditions inside the jellyfish's body, energy gets released in the form of light instead of heat. Almost the opposite of what happens when you burn something. This process is called bioluminescence, and it lets an animal glow using its own internal chemistry, with no need for any outside light source at all. This matters enormously in an environment like the deep ocean, where sunlight completely disappears past a certain depth. Down there, an animal that can produce its own light suddenly has a tool that almost nothing else in that pitch-black world has access to. And different deep-sea jellyfish species have found several completely different ways to put that tool to use. One of the clearest examples is a deep-sea jellyfish known for a defense strategy that looks almost nothing like typical self-protection. When this jellyfish is grabbed or attacked by a predator, instead of trying to swim away or hide, it lights up in a fast, spinning pattern of bright flashes across its entire body. This dramatic display isn't meant to scare the attacker off directly. It's meant to attract attention from something else nearby, ideally a larger predator that might notice the flashing light, come to investigate, and attack whatever originally grabbed the jellyfish. Researchers studying this behavior often describe it using the same basic idea as a car alarm. The jellyfish isn't fighting back itself. It's making enough noise in the form of light to summon a bigger threat that might scare off or injure the original attacker, giving the jellyfish a chance to escape in the confusion. Not every glowing jellyfish uses its light this way. Some species use bioluminescence for a completely different purpose, luring in prey. A small glowing light in an otherwise pitch-black environment can be incredibly effective at drawing in smaller, curious animals, either out of natural attraction to a light source or because the light resembles something the prey animal would normally want to investigate, like the glow given off by tiny plankton. Once prey gets close enough, the jellyfish's trailing tentacles, often lined with stinging cells, are right there waiting. There's also a defensive use of light that works in the opposite direction from summoning help, called counter-illumination. Some deep-sea animals, including certain jellyfish, produce a faint glow specifically on the underside of their body, matching the extremely dim light that occasionally filters down from far above. To a predator looking upward from below, searching for a dark silhouette against that faint light, an animal using counter-illumination can blend in almost perfectly, essentially cancelling out its own shadow using light instead of hiding in darkness. This raises an interesting question. If bioluminescence can be used both to hide and to attract attention, how does an animal make sure it's only glowing exactly when it wants to, rather than constantly giving away its position by accident? Many bioluminescent jellyfish are able to control their light production fairly precisely. triggering the chemical reaction only in response to specific stimulation, like being physically touched or grabbed rather than glowing constantly on their own. Some species can also control which parts of their body light up and how intensely, allowing different behaviors like a subtle defensive glow versus a dramatic full-body alarm display, depending on exactly what kind of threat or opportunity they're responding to. It's also worth noting that not every glowing sea creature makes light the same way a jellyfish does. Some deep-sea animals rely instead on colonies of glowing bacteria living inside special light producing organs in their body, essentially housing a separate living organism that does the actual light production for them. Jellyfish that use true bioluminescence, producing light entirely through their own internal chemistry rather than relying on bacteria, represent one specific evolutionary path among several different ways deep-sea life has found to solve the exact same basic problem: how to use light as a tool in a world with none. There's one more small but important detail that shapes almost every one of these light-based strategies, and it comes down to color. The vast majority of deep-sea bioluminescent animals, including most glowing jellyfish, produce light somewhere in the blue or blue-green part of the spectrum rather than red, yellow or white light. This isn't a coincidence. Blue light travels further through seawater than almost any other color before it fades out and becomes too weak to detect. Red light, on the other hand, gets absorbed by water extremely quickly and barely travels any distance at all underwater. By producing blue light specifically, a jellyfish's glow, whether it's meant to summon help, lure in prey, or blend into a faint background glow, can actually be seen from as far away as possible, making the entire signal far more effective in an environment where every bit of visible distance matters. Put all of this together, and deep-sea bioluminescent jellyfish turn out to be carrying around a surprisingly advanced piece of equipment, all built from simple chemistry rather than any complex organ system. A built-in alarm system capable of calling in outside help during an attack. A lure capable of drawing curious prey close enough to catch. And in some cases, a way of disappearing entirely by matching the exact dim light around them. All of it running on the same basic chemical reaction, glowing quietly in a part of the ocean that never sees a single ray of natural sunlight.